that is ready for the storage and processing of higher layers. It should get forwarded down. Here, one of the basic principles of this reference model is that the information processing is initiated easily and as close to the edge of the network as possible. So very near information that it is going to be taken. The data can be filtered or aggregated before being sent to the higher layers. So this is the major thing it is going. Also, it allows for the data to be reformatted or decoded, making additional processing by their system easier. By this, the critical functions is assessing the data to see that there are thresholds. Any thresholds are going to be there, crossed with any actions or alerts are to be sent. So this is the major layer where the informations are going to be checked properly. Next is the data accumulation layer, where the captured data is going to be stored in the applications, visible applications, where it is necessary the data is going to be shared. Query-based processing is going to be done in this. And data abstraction layer, here in this reconciles multiple data formats, because as I said, as sensors, different location, different data is going to appear. Those data are going to get collected and reformatting is going to be done, and consumes the constraint semantics from the various sources. Collection will be there from various sources, so reformatting has to be done. Confirms that the data set is complete and consolidated. Data is going to be given to the multiple data stores using virtualization. Next layer is the application layer, where it interacts with the data with the software applications. Applications may monitor, control and provide reports based on the analysis of the data. So as it is collected, so it is going to get. So here as application, major application, it is going to be that particular applications data is going to get provided. Collaboration and process layers. Here is consumption says the application information by collaborating and communicating with the IoT information. Often it shows or it requires multiple steps, because as a IoT, data is going to get transferred in the different locations. It is going to be more useful then. So this layer can change the business process and drivers based on the benefits of IoT. Because data is collected, everybody is collaborated, everywhere the data is needed. So based on the application to application, the IoT is going to be get. This is going to get provided. There is a simplified IoT architecture is going to be here. It's a 3-layer architecture. Framework is being designed like this. 2 parallel stacks. The IoT data management and compute stack, and the core IoT functional stack. One is core IoT functional stack is there, another is IoT data management and compute stack is there. Now the basic model, this is the basic model it is going to be. The applications are there, communication network is there, things are there. The similar layer here, it is cloud, fog and edge. Things always comes under the sensors and actuators, where the edge data is going to be present. For example, if you take the car, the sensors are going to be at the edge. They only will collect the data, and the actuators are going to, next level is actuators. Actuators are going to execute, the actions are going to be taken, and if still needs that information to be traced, then the communication network communications is going to happen, and there the process is going to be done. Then the If the data is going to be still it is required, it is going to get forwarded to the cloud where the data is going to be stored, and can be traced later. So like this, the simplified architecture also it is being designed for this IoT. So here that's what has been explained in the another detailed manner. The core functional stack can be expanded into a sub-layers. There is network functions. The communication layer is going to be broken into 4 things, that is 4 layers. The access network, gateway and backhaul network, then IP transport, and finally the operations on management subsystems, sub-layers. And in the case of application layers, it is divided into 2. It is the IoT often involves strong big data analytics components, and also the applications layer typically has both analytics and industry specific IoT control specific components. So both are going to be there. So whichever that it is required. So based on that, the data is going to be given. Second is finally the important thing where it is going to be there for both core IoT and data management. Second is the central part of the entire architecture, both from network connectivity and the data management whole scope. It is saying in this the extended view of the simplified IoT architecture, where the application, these two are similar, there is no change in that, but what is there in that application layer, how this communication layer is split again. Okay, so those things that we can see in this. So here it is saying that the applications are going to be like virtual vertical specific applications are going to SCADA and MDI. Then analytics is the way basically big data is going to be there. That's why analytics is going to be the part of that. Then in the case of communication, we have the IoT network management is there. There is 2 protocols, COAP and MQTT. There's a consumer application protocol and message queue telemetry support. The network transport layer is there. Next is gateways and backhaul networks, and access network, that is PAN and PLCs. There are so many things are going to be, applications are going to be. Let us see these things in the next step. Okay, so I already discussed about that. Application and analytics layer. Here, how the data is going to be moved still. The sensors, how it is getting collected and all these things. Let us see steps here. At the upper layer, the application needs to be processed and collected data. Not only the control the smart objects when it is going to be necessary, but to make the intelligent decisions based on the information that collected, and in turn instruct the things to be get executed, orders, the system to adapt the analyzed conditions or the changes behaviors are going to be get executed immediately. So here is sensors data is going to be there, been shown here. Actuators layer. Now you can see that in this low mobility, low throughput, the data here, the industrial pumps, motors, etc. It comes into that environment and home. So here fire safety and security controls. Then weather sensors is a low mobility, and food is also we least that we will be going to consider